Scientists and engineers communicate with faraway robotic spacecraft exploring our solar system. When scientists and engineers want to send commands to a spacecraft, they turn to the Deep Space Network, NASA's international array of giant radio antennas used to communicate with spacecraft at the moon and beyond. Operators of the Deep Space Network take commands, break them into digital bits, precisely aim these big antennas at the spacecraft.
Yeah, Deep Space Network. There's three large antennas positioned throughout the world. One's in the United States, one's in Spain, and one's in Australia. They basically cover 120 degrees angle of the sky from the Earth, if you know what I mean, from space. So 120 times 3 being 360 degrees. So they're giving you coverage from the Earth of space in every direction. Let's play a bit more.
And send those commands
Ah,
to
there
the
they are.
spacecraft using radio waves. But what are radio waves really? Well, to start with, you probably already know they're part of the electromagnetic spectrum, which includes other kinds of waves and light that you're familiar with. Electromagnetic energy is a type of energy that can travel through space as waves that have different properties, depending on the size and spacing of the waves.
Yeah, as you said, the size and spacing of the waves. So the wavelength, let's get this right. The wavelength at lower frequencies is higher. It's like inverse. So the lower the frequency, the longer the wavelength. Hence, sort of 198 kilohertz, which is Radio 4 long wave in the UK, is on the long wave band. Not all countries have long wave, but it's at 198 kilohertz and it's a long wave. Hence, they call the band long wave that the Radio 4 transmits on. At the other end, sort of the ham radio, amateur radio band around 430 megahertz is known as a 70 centimeters band, and it's called that because the wavelength is 70 centimeters. So, and to contrast that, 145 megahertz is 2 meters. So as you see, the higher the frequency, the smaller the wavelength. Let's continue.
These waves span a broad spectrum, from very long radio waves to very short gamma rays. The human eye can detect only a small portion of this spectrum, which is why it's called visible light. Radio waves are the longest in the electromagnetic spectrum, and the wavelengths used by the Deep Space Network currently range from about the size of a dime to the size of a dollar bill. Radio waves are all around us. We use them when we listen to music over the radio, or send emails from computers using Wi-Fi.
Yeah, Wi-Fi. In the UK, the main band was 2.4 gigahertz or 2,400 megahertz, but there's also, I think, there's a 5 gigahertz. I think in some countries there's a 6 gigahertz. So it's in the sort of gigahertz range. Like I say, UK, the main one is 2.4 gigahertz or 2,400 megahertz.
Or when we talk on cell phones, computers and
Cell phones or mobile phones, and UK, two bands, 1800 megahertz and about 900. Yeah, varies between countries and regions, and it's planned out by international institutions. About the reason for that is you don't get interference between adjacent countries and regions. So the bands and the frequencies do change slightly between regions.
are actually just high-tech radios. Radio waves also travel really, really fast, at the speed of light. That's 186,000 miles per second.
Yeah, I was watching something about Voyager earlier. In fact, it might come up on here, the Voyager 1 spacecraft, and it's so far away now that apparently it takes 21 hours for the radio signals to transmit back from it to Earth. And obviously you can see there's a speed of light. Sorry, the radio waves are traveling at the speed of light. So obviously there's a delay if you're so far away from Earth. was a delay wherever you are. That's why low Earth orbit satellites, which such as Starlink, have a lower latency, a lower delay than, say, a geostationary satellite, which might be 36,000 kilometers from the Earth, because there's a time delay for the signals going up to it and back. Whereas a low Earth orbit, by comparison to the geostationary satellite, which is 36,000 miles away, low Earth orbit satellite even will be less than 2,000 kilometers away. Hence nearer, less time delay, less latency, quicker communication. Let's continue.
But our solar system is also really, really big. It could take several minutes or even hours for the radio waves to reach a spacecraft. Once the spacecraft receive a signal, they execute commands, collect scientific data and never-before-seen images, and send all of that data back to Earth as digital bits, which are gathered by the huge antennas of the Deep Space Network and distributed to scientists, allowing them to learn a little bit more about how our solar system works. To learn more about the Deep Space Network, visit go.nasa.gov/about-DSN.
Yeah, and obviously things like the Voyager spacecraft, so far away, they need sensitive and large antennas on Earth to be able to help pick up the signals, because they're so weak and so far away, as well as there being the time delay. So I hope you found that interesting. This video has been playing from the NASA site, and as you see there, you've got a web link if you want to find any more information. Okay, where's the off button? Here we go. Thanks. See you soon.